Welcome to Study Loop.
In this problem, we are given a picture of a reaction at two different temperatures, 300 and 500 Kelvin, and we are asked to determine whether the reaction is endothermic or exothermic. To get started, let's take stock of how much we have in both of our conditions. At 300 Kelvin, for A2, those are the two red dots, and we have one of them. For B, we also have one, that's the blue dot. There is also 3 molecules of A and 5 molecules of AB. Now let's take a look at 500 K. This time we can see there are 3 molecules of A2, 3 atoms of B, 1 single A atom, and 3 molecules of AB. Let's think about this now in terms of our equilibrium constants. The equilibrium constant is products over reactants. So this is going to be A times AB over A2 times B. So 3 times 5 over 1 times 1 equals 15. Let's compare this to our equilibrium constant for our other situation. We're going to use the same equilibrium expression as before. So A times AB, that's 1 times 3 in the numerator, and A2 times B, that's 3 times 3 in the denominator. That equals 1/3. So with this information in mind, we're looking at how at 300 K, we have a Kc of 15, and at 500 we have a Kc of 1/3. This tells us that as our temperature increases, we are seeing Kc, our equilibrium constant, decrease. We are also seeing more reactants and fewer products. All of these tell us that this is an exothermic reaction. One way to think about this is thinking about heat as one of the products in an exothermic reaction. So when you increase the temperature and add more heat on the product side, that shifts you back towards the reactants. And since that's what we are observing here, we say this is an exothermic reaction.